Hello, everyone. I'm going to talk about the production of lexical tones with phonation contrasts in Kunshan Wu Chinese by school-age children. The acquisition of lexical tones involving creaky voice was previously studied in Mandarin and Cantonese, but creakiness in these languages is believed to be phonetically motivated by the low-pitch targets. However, non-motor phonation in tonal languages can also be phonologically motivated, such as breathy voice in Wentao and Wu Chinese, lax voice in Southern Yi. In this study, we focused on Wu Chinese, which features contrastive tone registers that are correlated with pitch and voice quality in the word initial position. The upper register tones are produced in modal voice, while the lower register tones are produced in breathy voice. And our earlier acoustic study has also confirmed such phonation contrast in the adult production of Kunshan Wu. So given that non-motor phonation can be an important cue in the production, the acquisition still remains unexplored. So this study aims to fill the research gap by investigating school-age children's production of Kunshan Wu tones. 6 Mandarin Wu bilingual children were recorded reading isolated monosyllabic words with various onsets, vowels, and the 5 unchecked tones. I'll demonstrate the example words. So it's like ga, 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 ga. A tone merger between tone 2A and tone 3A, so falling tone and high dipping tone, was also found among the adults. After we got the data, auditory judgment was conducted to decide whether each token sounded breathy to the native speakers. Tone space dispersion was then calculated, and acoustic measures, including spectral tilts and noise measures, were extracted from voice source. So here come the results. First, while the tone merger was found to be bidirectional for the adults, it was mostly unidirectional for the children, as we can see in table 2. Many tokens of tone 3A words were produced as tone 2A, while only 1 token or 4 tokens of tone 2A words were produced as tone 3A. So it's almost unidirectional. Besides, the tone merger was complete for only one of the children, M3, but still incomplete for the others. The auditory judgment results show that every child was more likely to produce breathiness in the lower register than in the upper register, which means all the children at least partially acquired the phonation contrast. As for pitch, the F0 contours of the children fairly resembled those of the adults, although there are some subtle differences that we want to do more research on later. For the acoustic correlates, we'd like to use 2 examples to illustrate. The first one is H1 minus A3, which means the amplitude differences between the first harmonic and the harmonic nearest to the third formant, which is a spectral tilt measure. The second is spectral peak provenance, CPP, which is a noise measure. So the patterns show that the lower register tones in pink and yellow generally had higher spectral tilts and lower noise measures, that is more noise, than the upper register tones. So the lower register tones were confirmed to be breathier than the upper register tones in the children's production. Finally, another interesting thing we found is that, for example, the child F1 showed the smallest tone space dispersion and a relatively high accuracy in distinguishing the merging tones, but a relatively low accuracy in distinguishing the phonation contrast. This should suggest that the acquisition of tonal categories, pitch, and voice quality is not necessarily parallel and concurrent, and there may not be a single indicator of the development of the lexical tones. Thank you.